So let's dive into one of the boldest breakthroughs in clean energy, turning nuclear waste into fuel for nuclear fusion. For decades, nuclear waste has been a costly liability, but a revolutionary process using superconducting linear accelerators is transforming it into tritium, the rare fuel that could, say that again?
Tritium.
Tritium. Linear accelerators is transforming it into tritium, that rare fuel that could power tomorrow's fusion reactors. So let's explore this and tell me what's going on in this radioactive. How do we turning this radioactive waste into the world's most valuable resources?
Yeah, this is cool. So scientists at Los Alamos National Laboratory, they've proposed a solution to two major problems facing nuclear energy. What do we do with radioactive nuclear waste? And how do we fuel the next generation of clean fusion reactors, not fission, fusion reactors? So Terence Taranowski is the research lead. He suggested using a particle accelerator to bombard existing nuclear waste with high energy particles, which would trigger reactions that would produce tritium, which is one of the rarest and most expensive substances on Earth at $15 million per pound. This tritium is essential for nuclear fusion. So it's the same process that powers the sun and promises virtually unlimited clean energy. And so the plan essentially turns nuclear waste from this liability into an asset. So instead of storing thousands of tons of radioactive material for hundreds of thousands of years, we could actually use it to create fuel for these upcoming fusion reactors that we've covered so much that produce clean energy with minimal waste. So think about it like this. We're turning garbage into gold, but for the nuclear age. So this is really cool. The thing with this is we're reusing kind of nuclear fuel. What are your thoughts on this, Craig?
Well, let's quantify this a bit. With over 90,000 metric tons of nuclear waste currently stored across the United States, this clean energy technology could be massive and turn a massive liability into a valuable resource. Instead of paying billions to store radioactive materials, we could be using them to fuel the next generation of power plants. And currently we have a tritium crisis. It's incredibly rare. The global reserves are only about 55 pounds worldwide. That's barely enough material to power 500 homes for 6 months. Each pound of tritium costs about $15 million to produce. So the United States currently has no domestic tritium production capabilities. It makes the country dependent on other nations for this critical fusion fuel. So this is very interesting. The new nuclear waste recycling process could produce 4.4 pounds of tritium annually using 1 gigawatt of energy input. This output matches Canada's entire yearly tritium production from traditional fission reactors.
That's crazy. Yeah, so the proposed system, which it centers around what's called accelerator-driven technology, or ADS, like we talked about, uses a linear particle accelerator to bombard the spent nuclear fuel. So unlike conventional reactors that rely on self-sustaining chain reactions, this system can be turned on and off like a switch. So makes it potentially safer, right? So when the accelerator fires protons into the nuclear waste, it triggers spallation reactions that release neutrons, which then react with surrounding materials to eventually produce the tritium through a series of nuclear transitions. So the system would operate in a subcritical configuration, meaning it can't sustain a runaway nuclear reaction, which makes it safe. And so I think this is a key component to nuclear fusion becoming the energy of the future. I'm going to make that bold statement, if this is a commercially viable solution. You're on mute.
It looks like it might be. 1 gigawatt systems equaling the production of carrying an entire fleet of tritium producing. Instead of paying billions to store, we're getting this stuff back. I guess the question is, what's it cost us to output that 1 gigawatt? And if we're getting 4.4 pounds, the annual tritium output from a 1 gigawatt system equals to production. So if we put a gigawatt power into this tritium, we get 4.4 pounds. Is that what we're getting?
I think so, yeah.
How much energy does that 4.4 pounds produce is what I'm trying to get at.
Well, we don't know yet because we don't have fusion reactors.
Yeah, and so we'll have to see there, but
well, we do have fusion reactors, but we don't have commercial fusion reactors.
Yeah. With tritium valued at 15 million per pound, even modest production levels create substantial economic benefits. A system producing 4.4 pounds annually could generate nearly 66 million tritium value. Sounds like an interesting business to be in.
Yeah, it does.
To get a particle accelerator together at all the systems to do this.
And I don't know if you said this, but nuclear waste energy, do you know how much is still usable of that nuclear waste that we're throwing out or storing? 95%.
Yeah, and this, again, is the old system. Well, that's why you say the new ones eat their own poop, as it were. They take the output and use it up, and you get very little residue left. But those are
just in the U.S. alone, like you said, we still have over 90,000 tons of nuclear waste stored. Over 90,000 tons.
Yeah, and when I say the new ones do that, they eat their own poop, I don't think there's any in the U.S. that I would consider the new ones. So they're still generating all of them, and I don't think there's any in Canada. But we're working on those mini nukes and a few of those other mini nuclear reactors. When I say nukes, people think of weapons that we're putting in our provinces and stuff for these. So I'm really interested to see how that stuff goes. But back to this. This is really exciting. It could really propel us forward, like you say, to a fusion-centric world. Like that 1 gigawatt can produce 4.4 pounds. Like there's no reason why multiple countries couldn't be running multiple systems to create all these at the same time. So you could create 20 pounds a year, for example. Yeah. So we'd have to sit back and figure out all of that. And once you have it, and we have fuel for the fusion reactors that ideally can sustain themselves, we're getting closer and closer to that. Yeah, we are close to almost free energy, I'm going to say.
Yeah. And as I was doing my research on this, did you know that the nuclear waste program itself in the U.S. has faced decades of delays, political obstacles, and the Yaka Mountain Repository Project was canceled after $15 billion in investment, which left spent fuel stored at reactor sites indefinitely. And Finland's Okalo facility represents the only operating deep geological repository for high-level nuclear waste, while other countries are struggling with similar storage challenges. So we desperately need a solution for this nuclear waste.
And I've said this before, but I might as well reiterate it since we're talking about it. The problem with nuclear is it takes too long and costs too much money. And when I say that, our election cycles are 4 years. So in Canada and the U.S., every 4 years, there's another election. Canada, give or take, they can call it longer, call it shorter, give or take.
Yeah.
So that means if the current party gets thrown out, the next party doesn't like nuclear, all the nuclear projects could get canceled. Yeah. And we're talking about 25, 50-year projects to build multiple nuclear plants that are costing billions and billions of dollars. And the private sector is very reluctant to put any money into that, knowing that, on a whim, it can be canceled by the next administration.
Yeah.
So that's why, Bill Gates, if you follow his stuff, he was talking years ago, and maybe he's not thinking the same anymore, that China was going to lead the way in nuclear because they keep the one government, and that's the way it goes.
Yeah.
So, it's not political. That's not this. It's not that. I'm just saying that we struggle with this. So I think the world is going to change now that we are taking AI seriously and thinking that AI is a national defense initiative and strategy. And we have to really build these huge data centers and power and whatnot. So we're going to probably start to see some restrictions on these things loosen up as a result, because we need the multi-gigawatt production for the data centers. And as a result, we'll need new nuclear, new fusion, new what have you. And hopefully that'll mean we'll actually get this.
Yeah.
So let us know what you think. Do you think this new way to create tritium is a future towards fusion energy, or is it another pipe dream? Let us know. Give us your comments. So, what do you got going on, John?
Yeah, so coming out end of September, definitely gearing up for Elevate. I know you're a partner with Elevate, aren't you, Craig?
Oh yeah, absolutely. So definitely we'll be doing something during the Elevate a week, probably a flowgrammer event, if nothing else. They're a partner of ours. Definitely go out and check it out. There's a lot of great events going on related to Elevate. That's why I said great events, sessions, program. Check out their schedule. Check out all the different lines of programs and stuff. There's always good things there. So definitely go check out Elevate. And check out Toronto Starts for our startup drinks, our startup investor drinks, and our flowgrammer events where we help people learn how to automate things in their business. And John, if people need funding, where do they go?
Yeah, come find me on LinkedIn. I just posted some news about the Shred program, but come find me on LinkedIn, send me a message, and we'll set up, we'll talk and see if it makes sense to find some non-dilutive funding for you.
Really appreciate everyone taking their time to watch or listen to this week. We'll see you again soon.
Thank you.